All right, we're going to be looking at Unit 4 review numbers 21 through 25. All of these questions pertain to recognizing the difference between vertices, faces, edges in a polyhedron. So I'm actually going to do 23, 24, and 25 first, and then I'm going to come back and do 21 and 22. So this is a pretty easy question, actually. You just need to know a little vocabulary in order to be able to answer it. So it says how many faces, how many vertices, and how many edges. I'm going to start with the vertices. So the vertices are the points where two edges meet, the points. So another way to think about them are to think of them as the corners of your polyhedron. So here they are, 1, 2, 3, 4, 5, 6, 7, 8 in this figure. And then if we determine the edges, then that's where two faces meet. Two faces meet at an edge, and they are lines. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I like to trace just to make sure I don't miss one. And then the faces are the flat surfaces. Excuse me. Sorry. The faces are the flat surfaces of the structure. So if you could be holding this, you would count like the top and bottom are two different faces, and the front and back are two different faces, and the two sides are two different faces. So in this case, I would have 1, 2, 3, 4, 5, 6 different faces in my structure. Okay, the next one is a pyramid. So if I want to start with vertices or corners, that would be 1, 2, 3, 4, 5. So this one we call a vertex or an apex, but we're going to count it as a vertex. So this one has 1, 2, 3, 4, 5 vertices. Next thing we're going to look at are edges. So those are my lines to connect my vertices, or where two faces meet. So that would be 1, 2, 3, 1 in the back, 4, 5, 6, 7, 8. So there are 8 edges. And then when I do faces, it's a little hard to show in this picture, but they're flat surfaces. There'd be 1 on the bottom, 2 on this two sides, and 2 front and back. So that's 2, 4, 5 faces. All right, one more time. For my vertices, I've got 1 at the top and bottom. So 1, 2, 3, 4, 5, 6 vertices. And then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges on this guy. And then my faces, I've got 4 on the top and 4 on the bottom. So that means I've got 8 faces. All right, the next thing is Euler's formula, and that's the formula that we talked about, the relationship between the vertices and the faces and the edges, where we say if you add, let me scooch down here for 21, vertices plus faces, and you add 2 to your edges, that they're going to be equal to each other. Another way to think about it is vertices plus faces minus edges is always going to be 2. Okay? So, easiest way to work this problem is to write your formula. Vertices plus faces equals edges plus 2. And then determine what you know. So you know 5 vertices and you know 7 faces. And then plug in what you know. So you're going to have 5 vertices, 7 faces is equal to E plus 2. Well, 5 plus 7 is 12 equals E plus 2. And then just solve for your unknown. So in this case, that will be minus 2. And your edges will be 10. So you're going to have 10 edges. All right. So all these kind of work the same way. So we're going to work the same, or number 22 the same way. So we have faces, or vertices plus faces equals edges plus 2. So we have 20 vertices and we have 78 edges. So if we plug 20 in here, we don't know faces, but we have 78 edges. Then we can actually just add 78 plus 2 and get 80. And we're solving for faces, so we can just subtract 20 and get the fact that there are going to be 60 faces. Okay, I hope that helps.